All right, here we go. We're going to see the power of tangent line approximations with this kind of problems. This is a classic example where you're asked to approximate a square root of something that's seemingly really hard to find the square root of using a tangent line. And there's no other instructions given. I love this kind of problem. So if we're approximating the square root of 24.5, what we're really doing here is we're going to be approximating the value of f of x equals the square root of x. That's what we're approximating, basically. So we need to actually pick an x value that works nicely for us. So what's really close to 24.5 that works really well in a square root function? How about at x equals 25? Because that's pretty darn close to 24.5, and it's got a nice square root. So at x equals 25, f of 25 is equal to the square root of 25, which is equal to 5. So we've got the point 25, 5. So essentially, we're making up the problem now. And if you look at this visually, and this is just like a rough graph, square root of x looks something like this. We're going to approximate 24.5 using a tangent line at x equals 5, right? So, sorry, at x equals 25. So here's x equals 25, 24.5 would be right here. The y value we get on this line is going to be a rough approximate of the true y value on the curve of the square root of x. Isn't that cool? So let's do it. So we need the tangent line equation. We've got an x value and a y value. I like to write out my template first. As always, y minus y1 equals m times x minus x1. And now from here, I've got my y1 and x1, but I need my slope at 25. Be very careful here. You do not want the slope at 24.5. We're concerned with finding the tangent line at a nice point, 25. So we need f prime of x. Well, we know that root x is the same as x to the 1/2. Take the derivative of that, you'll get 1/2 x to the negative 1/2, and that simplifies to 1 over 2 root x. And I like to simplify that because it gets it into a position to easily plug in 25. Negative 1/2 becomes 1 over root x. So f prime of 25 is equal to 1 over 2 root 25, plugging it in. And root 25 is just 5, so that's 1 over 2 times 5, which is 1/10. Beautiful. So the slope is a 1/10. So we've got our equation of our tangent line. Y minus y1 is 5 is equal to a slope of a 1/10 times x minus the x value, which is 25. So this is the equation of our tangent line. We are told that we need to use a tangent line to approximate 24.5. So all we now need to do is plug in 24.5. So y minus 5 is going to be, I guess we'll say approximately, well, I guess it's equal to 1/10 times 24.5 minus 25. Now remember, y is what we're solving for. So y is equal to, we add 5 to both sides, 5 plus 1/10 times, and this is going to be a negative 0.5. Ooh, very nice. And so that's what y is equal to. That's the exact y value on the curve, but y we're using to approximate 24.5. So y is approximately f of 24.5. So that's approximately 5 plus. And on the AP exam, you could leave your answer like this, by the way. So on that exam, just leave it. Or simplify it if your teacher wants you to. So negative 0.5 times 1/10 is negative 1/20. 5 minus 1/20. If you want to do it as decimals, you certainly can. If not, let's see. This is going to be 120ths, 99/20. Or, if you're a decimal person, 4.95. Right, that's it. Not so bad. So a classic kind of problem done right with a tangent line equation. And notice, our curve is concave down the whole time, so this approximation would be an over approximation of the true value. And what's the true value of the square root of 24.5? No one will ever know. It's an irrational number. The decimal goes on forever, so we got at least a nice approximation. Sweet.